Water, air, and soil. These three are the major resources which is mainly needed for all the living organisms to survive in this world. The unique properties of water enable it to play a dynamic role in shaping the landscape and creating special habitats for all living organisms. It is generally obtained from the rivers, lakes, and groundwater sources. Water pollution is the serious ecological problem we face today. Many countries are facing the critical challenges to supply the clean water without any pollution. Due to industrial development and the process of manufacturing changes, the water gets highly polluted and changes its physical and chemical properties, which creates harmful effects to all living organisms. Sugar mills, electroplating, tanneries, dyes, etc. are the major polluting industries which generate too much volume of wastewater with high toxic contaminants and disposed into the natural water bodies without prior treatment methods. A common ground for pollutants is their mode of entry into the water system. The waterways are subjected to entry of pollutants by direct discharge into the river water system, reactions and transport across the air-water interfaces, runoff and seepage with subsequent transport, reactions and transport across the water sediment interface. Under all conditions, entry of the pollutant is either in dissolved or particulate form or may be converted to these forms by chemical reactions. There are many methods available to treat the wastewater, and it is generally classified into three different stages: primary, secondary, and tertiary treatment process to remove the specific contaminants. The water treatment methods used by the industries are generally the same primary, secondary, and tertiary treatment methods which are used by the municipalities. Many industries are releasing wastewater of fairly uniform or predictable quality, and as the exact pollutants are known, it is often possible to choose the best treatment path for those particular pollutants. As new methods are invented or old methods improve, an industry can change to a better treatment.
Effects of heavy metal pollution. Mercury. In 1972, 300 persons were officially listed as its victims. Industries on the bank of Kalu River originates in Western Ghats, contains a lot of mercury and lead. A child drinks 1 liter of water, consumes 35 ppm of mercury in a week. Over a period of several months, this leads to the accumulation of over zero point 0.3 milligram of mercury, leads to Minamata disease. Lead. In the last century, the mining and smelting of lead has increased above the prehistorical level. All this has led to mental disturbance reflected by crime, culture degradations. Tap water contains quite a large amount of lead. Zinc. Even though zinc is an essential requirement for a healthy body, excess zinc can be harmful. Generally, increased exposure to heavy metals in the environment increase risk in developing cancer. Chromium. Chromium is a dangerous and may cause health problems including allergic reactions, skin rash, nose irritation.
Methods of removing heavy metal ions. Removing or reducing the heavy metal concentration from the aqueous medium is one of the challenging tasks for the researchers. There are many methods suggested by the researchers and scientists to remove the accumulated heavy metal ions from the aqueous solution as well as the industrial effluents. Due to the lack of laboratory facilities and need of skilled persons, availability of various chemicals and cost of treatment process etc., many of the methods were not used efficiently by the researchers. The following are the major treatment methods which are used in recent days to reduce or remove the toxic metal concentration from the aqueous medium: activated sludge process, chemical precipitation, coagulation and flocculation, electrochemical treatment, ion exchange, membrane filtration, adsorption. Adsorption process. Adsorption is the adhesion of atoms, ions or molecules from a gas, liquid or dissolved solids to a surface. This process creates a film of the adsorbate on the surface of the adsorbent. Adsorption is a surface phenomena, while adsorption involves the whole volume of the material. The process of adsorption arises due to the presence of unbalanced or residual forces at the surface of liquid or solid phase. These unbalanced residual forces have tendency to attract and retain the molecule species with which it comes in contact with the surface. Adsorption plays a significant role in many fields and promotes numerous applications of chemicals and industrial processes such as mixture isolation, air purification, water and wastewater treatment, industrial electrochemical cycle, highly diverse catalysis, sugar processing, process of vegetable oils, poison gases in the gas mask, etc. It has advantages over the other methods. The design is very simple and the investment is very low also. Very low sludge has been produced during the treatment process, but activated carbon used this technique may affect the adsorbed solids and desorption takes place. The other conventional treatment methods are successfully used in wastewater treatment method which contain a high concentration of heavy metal ions except the adsorption process. It is difficult to attain the permissible limit of heavy metal ions removal from the wastewater in low concentration. The conventional method are not effectively used due to the low efficient, high cost and high energy consumption. Comparing the other conventional method, adsorption has advantages like low cost, intensity to contaminants and flexibility in the design and operation. Also, this process does not result in the production of harmful substances as byproduct. In the surface of liquid or solid, the molecule forces are in the stable of unbalanced or saturated conditions. To satisfy the residual forces, the surface of solid comes in contact with molecular or dissolved substances due to this unsaturation. Because of this activity, the higher concentration of a species is present in the surface and creates bulky form. This concentration of surface phenomena on any medium is called adsorption. This is the unique process to remove the organic and inorganic substances from the wastewater. To treat the biodegradable and non-biodegradable matters in the wastewater, most of the physicochemical methods have been used. The activated carbon adsorption in both granular and powdered form. The following are types of adsorption may be distinguished: physical adsorption process, chemical adsorption process, activated adsorption process. From the organic waste, the carbon can easily dry with very low cost and it's preferably suitable for the removal of toxic contaminants from the wastewater. In this world, the utilization of natural waste is very low and has been a serious management problem. Hence, the production of adsorbent and activated carbon from the natural waste serves many useful purposes. The production of organic wastes of tobacco leaves are increasing day by day. It is estimated that these wastes are accumulated at the rate of 125.6 tons per year and creating a massive disposal problem. The major objective of this research work is to explore the adsorption capacity and adsorption kinetics of tobacco leaves from the uptake of heavy metal ions such as chromium, lead, and zinc from industrial effluents, and it's applicable for the treatment of natural wastewaters containing these heavy metals. The investigation includes batch mode, fixed bed, and column studies. However, the batch studies have been used to find out the adsorption capacity and its efficiency from the batch studies. The adsorption isotherms derives and it has conventionally for preliminary test before starting the column studies. Objectives: to prepare the adsorbent from tobacco leaves and convert them into the raw powder form, to prepare the granular activated carbon from tobacco leaves powder by adopting different activation process, to characterize the raw powdered adsorbent and activated adsorbent and evaluate the suitable adsorbent for the removal of heavy metals such as hexavalent chromium, lead, and zinc from the aqueous solution, to study the impact of variables such as pH, contact time, adsorbent dosage, concentration, and temperature on the adsorption efficient for the heavy metals removal through the batch experiment, to convert the most convenient absorbent from micro to nano in size using iron oxides for increasing the efficiency of the adsorption process, to study the effect of rate of flow and depth of the bed for the removal of heavy metal through fixed bed column analysis, to apply the optimum condition to the industrial wastewater for the removal of heavy metal concentration.
Tobacco leaves. Tobacco leaf, which is an ecological contaminant produced during most of the manufacturing of Indian raw tobacco, needs this inquiry. A BD is thinner and cheaper than a cigarette and is called a poor man's cigarette in India. BD is an Indian raw cigarette in which tobacco is wrapped in a shortcut part of the tobacco leaf and wrapped with a cotton cord. Tobacco leaf is used as a BD foil because of the ease to which it can be wrapped and its easy availability. This also has a good flavor, tolerance to oxidation, and fire retention capacity. Approximately 7,200 tons of tobacco leaf waste are produced annually in the industrial town of Solapur, India. Preparation of adsorbent. Activated tendu leaf powder. The adsorbent is cleaned with distilled water, followed by sun drying and dried in the oven at 60 degrees Celsius for 3 hours. To increase the absorption efficiency and stability, the raw tinto leaf powder is again treated with distilled water and concentrated sulfuric acid for about 24 hours. Then, this mixture was filtered with Whatman's filter paper and placed in the hot air oven at 80 degrees Celsius for about 10 hours. Preparation of metal ion solutions. The stock solutions of metal ions such as chromium 6, lead 2, and zinc 2 were prepared by dissolving the calculated amount of potassium dichromate, lead sulfate, and zinc chloride respectively in double distilled water. To obtain various design concentrations, the prepared water is diluted with double distilled water.
Instrumental analysis. Fourier transform infrared spectrography analysis was done by Capier potassium bromide pellet method in the spectral range of 4000 to 650 cm inverse for the adsorbents to find out the infrared spectrum of adsorptions or emission of the liquid. PIR spectrum ASCII patch 1.60 spectrometer used for this entire FTIR study. Scanning electron microscope analysis was used to find out the surface morphology of the adsorbent by the Leo Gemini 1530. SEM instrument was working distance of a 10 micrometer and a voltage of 15 kilowatts. Orbital rotary laboratory shaker was used in the entire batch adsorption studies with a constant stirring rate of 250 rpm. The atomic adsorption spectrometer AA6300 made in Zimatsu were used to find out the concentration of the heavy metal ions in the aqueous solution before and after equilibrium has determined. Using HANA pH meter with the combined glass electrode, the solution pH was measured in various levels. Conclusion. The adsorptions of chromium, lead and zinc has been investigated from the industrial influence using tobacco leaves powder as an adsorbent. The maximum removal efficiency of 99.6% of chromium, 75.21% of lead and 94.22% of zinc was attained at a pH of 2. The optimum adsorbent dosage level is 2 gram per liter. Contact of 50 minutes. Initial concentration of the adsorbate is 25 milligram per liter. Particle size of 10 micrometer. Acquisition speed 400 rpm with a temperature of 30 degrees Celsius. Based on the discussion and result of batch adsorption studies, it is evident that tobacco leaves were found to be the suitable adsorbent for the removal of heavy metal ions, chromium, lead and zinc. Hence, the selected adsorbent was used in the continuous fixed bed column for the further studies. The column is fixed with fine sand followed by the cotton at the top and bottom. Before applying the adsorbent bed into the column, the known concentration of heavy metal ion solution were passed to find out the changes in the efficiency of the adsorbent process due to the presence of sand and cotton. This represents the changes in the efficiency of adsorption before and after passing into the column without adsorption bed. It was found that the efficiency of the adsorbent has not changed from its initial concentration. Hence, sand and cotton does not play any vital role in the adsorption process.
Preparation of nanoadsorbents from the organic material is one of the challenging tasks in the modern technology. Many methods such as ball mill grinding, co-precipitation, chemical vapor deposition, flame synthesis, etc. were used to convert the size of the particles from microscale to nanoscale. But the iron-based nanoparticles are commonly used to remove the toxic heavy metals from the aqueous solution. These are the very simple and cost efficient method which cannot be produced any secondary contaminants. The surface area properties can be increased by modification of materials, dissolving the ratio of 1:2 with the solutions of ferrous sulfate heptahydrate and ferric chloride hexahydrate in the distilled water with magnetic stirring under the heating of 80 degrees Celsius. The oxides of iron nanoparticles were prepared. Further, 10 ml of ammonia solution was added in the heated solution and the mixture was furtherly added into the 15 gram of grinded tobacco leaf powder. Then the solution was allowed into the heating process up to 80 degrees Celsius with a constant stirring up to 30 minutes in the muffled furnace. Finally, the suspension was taken and cooled in room temperature, followed by washing and cleaning. The washing can be done by using the ethanol followed by distilled water for removing the black precipitates, separation and organic matrix held in loose conditions. In the magnetic nanoparticles, the unwanted residual particles were removed using the magnetic separation technique. The sample was heated in an oven at the temperature of 80 degrees Celsius for drying, and the particles were collected and used for investigation of heavy metals removal from the industrial effluent.
Analysis of nanoabsorbance. For analyzing the size of nanoparticles in the column studies and capturing the fine sample and its details, Joule GEM 1400 plus transmission electron microscope were used. For the confirmation of nanoparticle stabilization, these particles were allowed for zeta potential analysis to check the particles are polydisperse or monodisperse nature. The TGA and DTA analysis was performed to ensure the organic capping of nanoparticles. BET analysis also carried out for analyzing the porosity and area of surface of nanoparticles. The crystallization structure of nanoparticles were obtained by using X-ray diffraction method. The occurrence of metal ions on the absorbent surface has been investigated by energy dispersive X-ray spectrography. Also, to understand the hysteresis and magnetization of nanoparticles, BSM Lakeshore 7410 also carried out.
The samples shown in the figure are collected from electroplating industries and other industries situated in and around Coimbatore. The column studies were carried out in fixed bed type with a varying heavy metal concentration of 100, 200 and 300 mg per liter for chromium, lead and zinc respectively. In this entire study, the rate of flow was adjusted from 5 ml per minute to 10 ml per minute with varying bed heights of 5, 7.5 and 10 cm. From the above observations, the maximum adsorption efficiency was obtained for chromium 92.26%, lead 75.57% and zinc 89.36% with the following optimum conditions. The optimum rate of flow is 5 ml per minute, optimum bed height is 10 cm, optimum level of metal ion concentration is 100 mg per liter.